In this video, we're going to look at 3 questions that require you to calculate quantities about motion from graphs. Question 1 is here. Pause the video and try this question now. So when we have a velocity time graph, the total distance traveled is the area under the graph. So what we need to do is we need to calculate the total area under this graph. And it's made of 3 parts. It's made of this rectangle, this triangle, and this triangle. So the total area is going to be 5 times 100 plus the area of a triangle, which is half base times height. Half base is obviously 15 minus 5, and the height is 100. And then we're going to add on this triangle here, which again is half base, which is 35 minus 15, and the height, which is 100. Now you can see I'm ignoring the minus sign here. That's because we've asked for distance, so we don't need to care about direction. And also we're working out the area under the graph. So this is still an area, even though it's below the 0 line. So if I work this out, that is going to be 500 plus 500 plus 1,000, which is going to equal 2,000 meters. Part B says find the total displacement after 35 seconds. So here we have to recognize the direction now. In this first part of the journey, the person is going in this direction or some direction, and in the second part of the journey, they are going in the opposite direction. We need to find out where they end up in relation to their starting point. So the area of the first part, what we just worked out, is 500 plus 500, which is 1,000. And then we need to subtract the area of the second part, which is 1,000. So that means our total displacement is 0 meters. So actually they ended up exactly where they started. Question 2 is here. Pause the video now and try this question. In part A, we're asked to work out the speed at 3 seconds. Well, that's really easy. We just read off the graph and we can see it's about 7.5 meters per second. If you said slightly higher or slightly lower, I'm not going to argue with you because this is not the best graph. In part B, it says find the average speed between 0 and 6 seconds, between 0 and 6 seconds, which is up here. So it's a constant increase in speed, a constant acceleration. So we can use this formula to work out the average speed. So 0 plus 15 over 2 is 7.5 meters per second, and it's exactly the same as in the first part, which is what we would expect because it's a straight line, and therefore we can see it's a constant acceleration. In part C, we're asked to find out the average speed over the whole journey. Now we can't use this here because we've got this long period of time where the speed remains the same. So what we need to use for part C is that average speed is total distance over total time. So the total distance is found by the area under the graph. So the area under the graph is the area of this triangle, which is half times 6 times 15, plus the area of this rectangle, which is 10 times 15, which is, 3 times, so that's 45, plus 150, which is 195. And then the time is 16 seconds. So plug that into the calculator. Let's see what we get. We get our average speed is 12 meters per second. Question 3 is here. Pause the video now and try this question. Here we have a speed time graph where the speed is changing. So it is getting faster, it is accelerating, but the rate of acceleration is slowing down. What's the initial acceleration? Well, to find out the initial acceleration, we need to draw the tangent on our graph at the starting point. And we need to work out the gradient of this tangent. So that's going to be 30 over 10, which is 3 meters per second squared. Part B says find the total displacement. So we want the area under the graph. Now, the area under the graph is a bit harder here because we can't use a triangle and a rectangle, or some of you might have been wondering why I didn't use the trapezium. You can, of course, use the area of a trapezium. That would, of course, work. So here, we could approximate this. There's lots of little trapeziums, but the easiest way usually is just to find the area by counting the squares. So what we need to do is work out what one square represents. So one square is a change in distance of 4 times by 5, which is 20 meters. How many squares in total? So we literally need to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So there's 65 whole squares. And then we need to estimate all of these bits here so we can just start to kind of pair them up. So that's about 1. That's probably actually a whole 1, 2, 3, 4, 5, 6, 6.5, 7, and then 8, 9. We'll just round that up. So plus 9 more, which is 74 squares in total. So therefore we have 74 times by 20 meters per square, which is 1,480 meters. And in an exam, there would always be some kind of leeway to account for the fact that it's not possible to get an exact answer.